All right, welcome back, guys. Let's talk a little bit more about those quadratics. Sometimes we're going to have information, and what we need to do is come up with the equation of the function. Before we had the equation, we found the vertex axis of symmetry. What if we know the vertex and the axis of symmetry, but we want the equation? That's what we're going to be working on. Okay, so first of all, let me go backtrack here. If you are told what the vertex of the equation is, you almost have the whole equation right there. Because remember, we used y equals ax minus h squared plus k. When we have the vertex, we have h and we have k. The only thing we don't know is what a is. Okay, so suppose the vertex is at negative 2, 5. We plug that into our vertex formula. We have almost the whole equation. All right, since the x is a negative 2, that makes this plus 2. The k is positive 5. So really the only thing we need to do is find out what that a is. Well, in order to find that, we're going to need to know more about the graph. Perhaps 1 point would be all we need to know. So let's continue this example. Suppose we know that okay, let's try a different one. No, it is the same one. It's the same equation. We know that the vertex was at negative 2, and see, now I already forgot what it was. Let me look. Negative 2, 5. There we go. Okay, so it still has that vertex, but we know that it also goes through the point 4, negative 3. That's all we need in order to figure this equation out. So we had the skeleton of the equation from before. If we know that it goes through negative 4, 3, all we need to do is plug those in for x and y, and we can solve for a. So in doing so, it would look like this. I'm just going to plug y in, plug the x in, and solve for a. In this particular case, our a ends up to be negative 2. So now that we know what a is, we can put the entire equation together. Y equals negative 2, x plus 2 squared plus 5. So again, if you have the vertex, the only thing left for you to find is what that a term is. But there will be other situations. They're not always just going to give us the vertex. They may give us something like the x-intercepts. And so putting this together, I want you to think back a little bit. Back to the days when we had an equation like this and we had to solve it. First thing that we did was factor, and then we knew that each of those factors were actually zeros. So now instead of getting the equation and finding the zeros, we are going to get the zeros and find the equation. So we're going to start by plugging those two into parentheses and multiplying it out. So let's say that we know that we have zeros at negative 5 and 6. And we need to find an equation for that function. First I want to point this out. Notice I didn't write find the equation. I wrote find an equation. Because there could be a whole bunch of different parabolas that go through the same zeros. I could have this parabola. I could have this parabola. I could have this parabola. All those could go through there. What's the difference between those? The a term. This would be a skinny a. This would be a fat negative a. Okay, so we're going to go through and solve it, but keep in mind that the equation that we get initially is just one of many possibilities. All right, so let's plug those into parentheses, distribute it, and our base equation would be y equals x squared minus x minus 30. That's the simplest of all parabolas that would go through those two zeros. A coefficient in front of the x can alter the graph, yet still result in the same zeros, like I said. So in addition to this as being one of the possible equations, I could multiply the whole works by a -1 and get the same graph, but it would be inverted. It would be upside down. This would still be an equation that has a 0 at -5 and 6. Multiplying it by 10 would make it a very skinny graph, but it would still have the same exact zeros. All right, that's that for this video. Adios.